You're listening to Würth Elektronik's What's Up radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our very own Würth Elektronik technical specialists. We're going to shine a light on our topics like energy harvesting, wireless power transfer, EMI issues, and today, high bandwidth uncompressed video connectivity for medical diagnostic equipment. You can tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Elektronik's What's Up podcast. Well, as we all know, the technological overhaul that is taking place in hospitals and medical centers is undoubtedly improving medical procedures. Quite often, we are hearing of surgeries that are being performed on the West Coast while the surgeon is located in an entirely different country. Doctors and health professionals actually benefit from operating with the highest possible video image quality for the most accurate representation of patients' conditions. Now, with the advent of medical-grade visualization systems, procedural workflows have been improving, and high-quality, zero-latency, uncompressed video images are now being transmitted over long distances for better collaboration, education, and monitoring. This podcast is based on a paper, and it introduces high-bandwidth, uncompressed video connectivity for medical diagnostic equipment based on the Valens chipset VS3000 HD-Base-T reference design solution, developed in collaboration with Würth Elektronik Passive Components. So first, we will start off with the basic requirements that are needed for these visual medical diagnostic systems. Well, the advanced medical imaging systems really demand high bandwidth connectivity and increased video performance. This means that introducing new requirements in the operating room include color accuracy with high dynamic range, or HDR, high quality imaging, which is uncompressed video, real-time zero latency video distribution, long-distance transmissions, flexible and efficient infrastructure, range of supported interfaces, and cross-vendor interoperability. HD-Base-T enables high-bandwidth, long-distance, high-quality video images to be transmitted in real time over a single cable while supporting interoperability between different devices, and this enables a visual medical diagnostic system connected inside and outside the operating room. But what is HD-Base-T? Well, HD-Base-T is a global standard that allows for the convergence and distribution of the 5-play feature set, which is audio, video, Ethernet, controls, USB 2.0, and up to 100 watts of power over a single LAN cable, Cat6 or above, for up to 100 meters and even up to 1,000 meters over optical fiber. Now that we have a very basic understanding of what HD-Base-T is, what are the benefits of using it for medical applications? Well, our first benefit is real-time transmission. During surgical procedures, accurate and real-time video images are very critical, and HD-Base-T delivers uncompressed UHD video. This enables the best possible quality image with virtually no latency, since it doesn't compress the data. Another benefit we have is the superior performance. When using diagnostic imaging systems such as MRIs, displaying X-rays, or conducting endoscopic procedures, medical professionals depend on high resolution and color accuracy, with no loss of visual information. HD-Base-T provides an advanced connectivity solution that meets the high demands of medical visualization systems, and it also enables bit-exact transmission of high-bandwidth data. And one of the biggest advantages is the space-saving design. It's the one-cable solution. With the proliferation of advanced digital video imaging, more devices and cabling needs to fit into small and crowded procedure rooms. HD-Base-T can improve workflow efficiency by reducing cables and connectors, facilitating sterilization methods, and increasing flexibility of the equipment location. And now we'll go on for the evaluation kit of the HD-Base-T IC for medical grade applications. Now, today we are talking about the Valens Semiconductor's VS3000. This is integrated circuit, leverages the HD-Base-T Spec 3.0 standard technology, and it also features HD-Base-T port duality, where the same chipset can be configured to operate as either a TX transmitter device on the video source side or an RX, which is the receiver device on the video receive side. The same design of TX and RX devices brings a considerable cost savings for manufacturers. So in order to evaluate the characteristics of the VS3000 chip family, Valens Semiconductors has come up with an evaluation kit, and this demonstrates the implementation of the device's feature set over single Cat6 cable. The data transfer between HD-Base-T, TX, or RX and the peripheral device is shown in our picture here. Now, in order to achieve a connection with a network cable that satisfies both the high-speed signal output as well as the electrical isolation between the source and the receiver, then a signal transformer is required. The design of the above-mentioned transformer can actually be quite challenging because the requirements given from the medical applications. First of all, to ensure long-distance signal transmission, Cat6 and above are recommended for the network cables. A withstand voltage of 4,000 VRMS per minute is required to meet IEC 60601, technical standard for the safety and essential performance of the medical electrical equipment. So what we've used is the HD-Base-T connection that's made up with a 4-channel HD-Base-T front end routed to a Cat6A RJ45 connector through our Würth Elektronik WLAN HD-Base-T transformer. This is a 10 gig base-T PoE transformer with 4 pairs, up to 150 watts power capability, and 4 kilovolts isolation voltage, specifically verified for the VS3000 interface. The isolation requirement, as well as the normal operating voltage requirement of 250 VRMS, are met with specific design of the electrical spacing. This is the creepage distance being 8 millimeters and the electrical clearance is 5 millimeters. Furthermore, the transformer windings are created with reinforced insulation. The VS3EVK implements the HD-Base-T power over HD-Base-T POH. Now, per POH, one side is the power supply PSE, or power source element, and the other side is the remote side, and this accepts power delivered. It's also called the PD, or powered device. On the cable side of the HD-Base-T transformer, the center taps are connected to the POH PD controller. Long-distance, high-speed transmission, POH power supply, may bring some EMC issues. It can also be shown how the signal transformer addresses isolation, insertion loss, and return loss requirements of HD-Base-T applications without decreasing the system performance. Now we're going to move on to the circuit considerations in an HD-Base-T application. Since the data rate is 16 gigabits per second and the connection is POH, the power path has to go through the center tap of the signal transformer. This creates common mode noise propagation in the data transmission. Typically, the clock source of the IC also generates noise at its frequency and its multipliers. So, to overcome these issues, common mode chokes are integrated in the signal transformer, and we can actually see this in our image with different common mode rejection ratios at different frequencies. Improved rejection of common mode noise by adding built-in common mode chokes on the phi side of the network transformer can be shown in our next figure. So, by adding common mode chokes to the transformer, the network cable radiation is effectively suppressed. Noise problems can also arise from the POH transmission, so a flyback transformer is used to provide power to the PD, capable of stepping up the input voltage to 56 volts. Noise generated by isolated power supplies, which may cause conduction and radiation problems, require additional common mode chokes close to the power supply to filter this type of noise. Chokes like the WE SL5 and the SL5HC series for PoE power supply filtering actually achieve high common mode impedance over a wide frequency band. And in this evaluation kit, WE SL5HC has actually been selected. It is 744273102. The transformer does not provide protection against ESD or surge impulses. So since these voltages are associated with rapid current increases, they can actually couple into the transformer from the cable side to the VS3000 chip and actually damage it. So it's recommended to connect each signal line between the transformer and the PHY chip to the TVS diode, as highlighted in our next figure. The TVS needs to be placed between the VS3000 and the network transformer, but as close to the network transformer as possible. This will provide the first protection in case ESD noise enters the system. The TVS is connected beside the signal line and ground to the reference ground of the VS3000 and the original side of the network transformer, not the earth PE. So in conclusion, HD-based heat provides an elegant solution to several requirements in the medical sector, and it has the ability to converge multiple peripheral interfaces into one interface and achieve long-distance bit-exact, zero-latency transmission of high-bandwidth signals through a single network cable, saving cabling space in the operating room and outside while ensuring compatibility between different devices. The Valens VS3000 chip represents an ideal device to optimize connectivity for audio and video transmission. To ensure the connection's high level of performance according to the HD-based specification, it's recommended to follow the chip manufacturer's reference design, and it uses high-quality electronic and electromechanical companion components that supports the Valens chipset on the board. For this purpose, the HD-based signal transformer is designed from Würth Elektronik to meet medical-grade voltage withstand requirements, ensuring high-quality signal transmission in terms of EMC performance, as well as the filter components that provide the finest solution to meet the requirements of the medical applications. As with all podcasts, some images and videos are unavailable based on the streaming service. To access all videos and images, click the link provided in the description or visit the Würth Elektronik YouTube page. You can also find the entire line of Würth Elektronik components discussed today by visiting Würth Elektronik online. There you can find all the transformers, TVS diodes, and the Valens reference designs, along with related components available. And for any questions, click the icon to talk with our live chat team. You can also test drive the online tool Red Expert completely free of charge. Using this tool, you can download datasheets, make comparisons, and easily order free samples directly from the site. You're listening to Würth Elektronik's What's Up radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Würth Elektronik technical specialists who are going to shine a light on interesting topics, such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Elektronik's What's Up podcast.